In the beginning, there was darkness, and then, bang, giving birth to an endless expanding existence of time, space, and matter. Now see further than we've ever imagined, beyond the limits of our existence, in a place we call the universe.
The universe is vast, wondrous, electrifying. But for space travelers looking for a thrill ride, it could be a one-way ticket.
It's a place from which you can't return, or at least not in the form in which you went in.
Go where no one has dared to venture. Take a virtual tour of the deadliest places in our galaxy and beyond. It's the ultimate frontier adventure. Space travel. But when trekking through the galactic jungles, one must steer clear of the cosmic hot zones, places teeming with violence and intrigue.
There are dangerous places, certainly very energetic phenomena that are a lot more powerful than atomic bombs being detonated, infinitely more powerful.
The universe does seem to be a very violent place. It seems to have been born in a violent explosion called the Big Bang, and there's all sorts of violent processes going on.
On December 27, 2004, satellites picked up the greatest cosmic explosion ever recorded. A blast 30,000 light years away, which had the power to briefly alter our planet's upper atmosphere. The blast was caused by a magnetar, the densest and one of the most dangerous stars in space.
The magnetic field strength of a magnetar is about 1,000 trillion times the magnetic field energy of the Earth. And for reference, this would wipe the information off a credit card at a distance of about 100,000 miles away. Now this distance is sort of half the distance to the moon, so it's very nearby by astronomical standards.
These mischievous stars have the strongest magnetic field in the universe. Scientists have confirmed 12 of these rare stars in our galaxy, and there may be more. Caltech's Brian Cameron scans the Milky Way for these strange stars.
Magnetars are a special class of neutron stars with ultra-strong magnetic fields, the densest form of matter in the universe. The first magnetar showed itself in the form of a high-energy event that was detected in the late 70s, although at the time we didn't know that it was a magnetar. It wasn't until the early 90s that researchers suggested that these objects were dominated by magnetic fields, and that the magnetar theory was actually confirmed.
Magnetars are born out of the death throes of massive stars. When a star dies, it begins to collapse and go supernova. Sometimes a dense neutron star forms from the cinders of that supernova explosion. During the process, a few neutron stars become magnetars, which possess a strong magnetic field. These stars eject high-energy emissions of X-rays and gamma rays.
We think that normal neutron stars are born from regular stars that are something like 10 or 20 times the mass of the sun. But there's evidence that magnetars are born from possibly even more massive stars than this, something like 40 times the mass of the sun.
Typically, a star of such mass would be too heavy to form a neutron star. Instead, its mass would collapse into a black hole.
Black holes are formed from cramming a certain amount of mass in a certain volume, and for whatever reason, these stars are unable to do that.
One theory is that some massive stars undergo a weight loss program right before exploding as a supernova, losing 90% of their mass. So instead of collapsing into a black hole, the emaciated star becomes a neutron star with extreme magnetic powers. When the magnetic force gets incredibly strong, it deforms the magnetar's crust, creating seismic events called starquakes on its surface.
And eventually, this crust breaks under the stress, and the magnetic field reconfigures itself into a lower energy state. And when this happens, a fireball is launched off the side of the star. So starquakes on neutron star surfaces are thought to give rise to these giant flares that we see. After a magnetar undergoes one of these flares, it outshines all the stars in the galaxy for the few tenths of a second that it's taking place.
Within these giant flares are short bursts of gamma rays which move at the speed of light.
The giant flares from magnetars are gamma ray bursts. They're very short in duration, less than a second, and have very hard X-ray spectra compared to another class of gamma ray bursts.
If a deep space traveler veered off course and was unlucky enough to pass within 700 miles of one of these massive objects, the consequences would be horrific. The magnetic field of the magnetar can literally warp the atoms in human flesh, and its gravitational forces would tear a person apart. So then, how close would a magnetar have to be to wreak havoc in our solar system? Some suggest that a blast from a magnetar even 10 light-years away could produce cosmic chaos that would destroy our ozone layer and cause mass extinctions.
The chances of that happening are so low that, they are completely implausible. It would be no different than a regular star passing through the solar system. And we know that the regular star has not passed through the solar system since the solar system formed.
Scientists think that magnetars are only a few thousand years old and will become dim after 10,000 years.
We're just now starting to understand the life cycle of magnetars. We think that they're very young, but how young is still uncertain.
In addition to magnetars, satellites and ground-based observatories have been picking up other violent things in space. Scientists have now confirmed the existence of a phantom-like force that's so strong that it might very well be the most vicious phenomenon in the universe. Stealthy filthy villains haunt each and every galaxy. One particular beast tears up anything in its path and gobbles it down like a cocktail hors d'oeuvre. It's one of the most bizarre and destructive phenomenon in the universe, a black hole.
I think a black hole is the place which is more violent than anywhere else in our universe.
It's like going over the edge and you can't get back. It's fatal attraction, I suppose.
A black hole is a region of space where the pull of gravity is so immense that nothing can escape it, not even light. Astrophysicist and triathlete Ferial Ozel is attempting to unlock the mysteries surrounding this elusive cosmic force.
In a black hole, the gravity is so strong that no other force can compete with it, so everything collapses to a single point.
Ozel says whatever has a close encounter with a black hole will fall victim to its relentless tidal force of gravity.
Imagine you're swimming in a pool and there is no current. You can go whichever direction you want. Now imagine you're taken out of this pool and you're in a river. Imagine a current that is much, much, much stronger. That the only direction that you could go would be with this current. The space around the black hole acts like this wild river. You could never fight this enormous drag that you feel.
As an object approaches the edge of the black hole, called the event horizon, it reaches the point of no return.
As you come closer and closer to this event horizon, you would already be approaching this extremely fast motion of space under you. And your only future direction is now into the black hole.
The idea of the black hole as a whole sometimes can be a little bit confusing. What it really is, in some sense, it's a place from which you can't return, or at least not in the form in which you went in.
Black holes are difficult to detect because, as the name suggests, you cannot see one by itself because it's black. But scientists have spotted a black hole when its gravity affects something else in space, such as a passing star.
A completely isolated black hole would not be visible. What we really see from a black hole is actually the hot material that's swirling around it and that's being sucked into it.
So in the neighborhood of these powerful black holes, you'll get a lot of radiation resulting from the black hole pulling in material and stretching it and twisting it as it's falling in.
Black holes consume anything in close range, and there are billions upon billions of them prowling the universe. Astrophysicist Andrea Ghez is one of the world's leading black hole hunters.
Black holes are not picky eaters. They'll dine on whatever get nearby. So they will happily eat gas. They will happily consume a star or a planet. When a black hole dines in a star, it does so first by tearing it apart. You might think of silly putty being stretched out, and then it just streams on in, sort of like water going down a drain. It's completely pulverized.
Black holes are produced, we believe, by the collapse of the core of a massive star, something like 25 or 30 times the mass of the sun or more. When it comes to the end of its lifetime, a massive star burns its core all the way past helium, carbon, nitrogen, oxygen, all the way to iron, which has no more nuclear fuel. And when that iron core builds up to a certain mass, there comes a point where it can no longer support itself, and the core will collapse all the way to a black hole, producing at the same time a supernova.
The supernova sends out explosive amounts of energy, so anything in its vicinity will get obliterated. Then the remnants of the explosion fall into a newly formed black hole. And it seems the key to the black hole's allure is gravity.
Gravity will pull things around, just like the sun's gravity pulls the planets around. In fact, stars will happily orbit the black hole for most of its life and won't actually be sucked in. These stars are actually safe from the fatal attraction of the black hole. But if you do venture too close, like extremely close to the edge, then you do get sucked in.
Scientists believe there are millions of wayward black holes throughout our galaxy, the Milky Way. And because we can't readily see them, one could be right next door. So how close does something have to be to get sucked into a black hole?
Too close to a black hole is about the distance between the sun and the Earth, but that is certainly too close.
For future space travelers, death by a black hole would be a violent way to go. The method by which a black hole could kill you depends on how big the black hole is. They come in two categories. Most of them are the stellar mass black holes, which are 5 to 30 times the mass of our sun.